This is section 5.2, right triangle trigonometry. We're going to begin with defining trig functions of acute angles. So our acute angles are angles that are less than 90 degrees, and in a right triangle with an acute angle, the longest side in the triangle is the hypotenuse. And it is always, this is really easy to remember, opposite the right angle. So let's take a look at that. Here's our right angle, and that side that's right across from that right angle is our hypotenuse. The leg that lies on one ray of angle theta is called an adjacent leg. And the leg that lies across the triangle from theta is called the opposite. So you are either adjacent to the ray of angle theta, that leg, or you are opposite. And as you can see, if this is theta, then the side opposite of theta is that side. Okay, so we'll be using opposite and adjacent a lot. So let's go ahead and look at our definitions and we'll work these examples. So we will be defining these functions, all of these functions, and we'll be using these throughout the course. So we have the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. So taking a look at this, we like to use this SOHCAHTOA. And so the sine is the opposite divided by the hypotenuse. You can see it there. The cosine is the adjacent divided by the hypotenuse, and the tangent is the opposite divided by the adjacent. And you can see the three that I just stated right here. So we will take those side lengths and divide them. Now, what's interesting here, the cosecant, if you look closely, we have the hypotenuse divided by the opposite side. So what do you notice? It is the reciprocal of the sine. So really, the cosecant is 1 divided by the sine of theta. It's the reciprocal. And then likewise, the secant is 1 divided by the cosine of theta, because the cosine of theta is adjacent over hypotenuse, and the secant is hypotenuse over adjacent. So you may remember these like that. And the cotangent, you guessed it, is the reciprocal, or 1 over the tangent. So that would be 1 divided by the tangent of theta. So reciprocating that. Okay, let's use this example to the right. We have our right angle right here. So obviously this is our hypotenuse, and our adjacent side is 24, and our opposite side is 7. We are opposite that theta. Okay, so if the sine is the opposite over the hypotenuse, we will have 7 over 25. The cosine is adjacent over hypotenuse. That would be 24 over 25. The tangent of theta is the opposite over the adjacent, which is 7 over 24. And the cosecant, we could just reciprocate the sine and write 25/7. The secant, we could reciprocate the cosine and write 25 over 24. And the cotan theta, we could reciprocate and write 24 over 7. Okay, so these are very, very important when we're looking at these acute angles. Now, let's evaluate some trig functions of acute angles with some different triangles. Let's mark this triangle. Remember, opposite that right angle is the hypotenuse. Across from theta is the opposite. We don't know what that is, so I'm going to write x equals. And then this 3 is the adjacent. Okay, now what do we need to know about a right triangle? You probably already remember this, is that the sides of this triangle, so we have x, y, and z, x squared plus y squared is equal to z squared. So those two sides of the right triangle, each individually squared is equal to the hypotenuse squared. So we're going to first use this Pythagorean theorem with it, which is this. To find the length of the missing side. And then we'll find the exact values of the sine and the cosine of theta. Okay, so let's go ahead and fill in what we know. We don't know what x is, so x squared plus 3 squared is equal to 4 squared. So we have x squared is equal to 4 squared minus 3 squared, which is 16 minus 9, which is 7. So x is equal to the square root of 7. Okay, now that we have x equal to the square root of 7, we can fill that in. And now we can find the sine and the cosine. So the sine of theta is the opposite over hypotenuse. Remember, so ka toa, so opposite over hypotenuse, and that is equal to, I can write here to the right, and the opposite is root 7 divided by 4, which is the hypotenuse. So let's try the cosine of theta, and remember that's adjacent divided by the hypotenuse. We can write that hypotenuse right now in that denominator, and the adjacent was 3. Let's try another example. Given an acute angle theta, if the tangent of theta is equal to 5/12, then find the secant of theta. So the most important thing, I think, would be getting this right triangle sketched. And then let's place what we know. So isn't it true that the tan of theta, and then this is theta, the tan of theta is the opposite over the adjacent. And so they gave us 5/12. So this side must be 5, and this side must be 12. So we just need to know what z is, this hypotenuse is. So we can have 5 squared plus 12 squared is equal to z squared. So we have 25 plus 144 is equal to z squared. And that's 169 equals z squared. And of course, the square root of 169 is 13. So now we know that z is equal to 13. And once we have this, now they want the secant. And that's pretty easy, because now we can say that the secant of theta, and remember, we can go up here and look at the cosine is adjacent over hypotenuse. So this would be the hypotenuse over adjacent, and that's equal to 13 divided by 12. Now let's look at some trig function values for special angles. And so we have an isosceles right triangle and a 30, 60, 90 right triangle. And as you notice, we have these written on here, and it's very nice because we have 1 and 1 written there, and then we have 1 and 2 written here. So what are we going to look at? We're going to take our time and say that this side z, z is equal to 1 squared plus 1 squared, and that's 2. So z is equal to the square root of 2. And that is really what's written, supposed to be written right there, the square root of 2. Okay, let's do that for this other angle. We have z here. We have z is 2, so we could have x is 1, and this is y, and then we're given 2. So what would we have here? We would have 1 squared plus y squared equals 2 squared. Y squared equals 4 minus 1, which is equal to 3. So y is equal to the square root of 3. So these become very, very handy. And as you can see, you don't really have to memorize if you have these written down. So let's take a look at the sine and the cosine, okay? So if we have theta equal to pi over 6 or 30 degrees, how would we fill in this table? Well, it's really nice because if you take step 1 and you just write one, 2, and 3. And then in step 2, if you'll just write the square root of those. And so we have the square root of 1, the square root of 2, and the square root of 3. And then in step 3, we're going to divide by 2. So we'll have the square root of 1 over 2, the square root of 2 over 2, and the square root of 3 over 2. And it makes it kind of neat because then we can fill the table in really nicely. And of course you can see that this is 1/2 root 2 over 2 and root 3 over 2. I'll pull this down. Okay, so let's go ahead and fill in the sine and with each of these angles. So we'll write those 1/2 the square root of 2 over 2 and the square root of 3 over 2. And as you can see, that corresponds to every one of these angles, okay? Now, how about the cosine of each one of those angles? We'll go backwards with 3, 2, 1, and we'll have the square root of 3 over 2, square root of 2 over 2, and then 1/2. So sometimes it's nice to have those trig functions in that table ready to go. So now we're going to find the exact value without the use of a calculator. Sometimes these can be a little bit tricky, but let's go ahead and begin. So if we need the tangent of pi over 3, if you can remember, that's going to be, the tangent is the sine divided by the cosine. So that's the sine of pi over 3 divided by the cosine of pi over 3. And the secant is 1 divided by the cosine of pi over 4. So looking at this table, the sine and the cosine here, we have 1/2 divided by the square root of 3 over 2. And then we will have, whoops, I had those backwards because we are on pi over 3, which is right here. So we have the sine is the square root of 3 over 2 divided by 1/2 minus 1 divided by, and now we're going to go to the cosine of pi over 4, which is the square root of 2 over 2. And then we will have, let me see if I can make this a little bit smaller. And then this is just the square root of 3. And now if you have 1 divided by, let's write that over here. The square root of 2 over 2, 1 divided by that is 2 over the square root of 2. So if you multiply root 2 over root 2, you will end up with just the square root of 2. So what's the square root of 3 minus the square root of 2? A little bit tricky there. Okay. And you can see here, you could also have gotten those. Here, the tangent of theta is the square root of 3, and the secant of pi over 4 is the square root of 2. So we kind of did it the long way, but I really wanted to show you where those values come from. Okay? Now, let's try this next one, and we will use the table this time. So we have the cosecant of 30 degrees, which is 2. Oops. Minus, and then don't forget we have this 2 times the sine of 45 degrees, which is the square root of 2 over 2. So we have 2 minus the square root of 2. And you can fill in all of this from the triangles. So let me make a note. So all of this can be filled in from the triangles. Okay, so let's keep going. Now we have just talked about the cosecant is 1 divided by the sine, and the sine is 1 divided by the cosecant. They're reciprocals of each other. I think it's easier to remember these. The secant is 1 divided by the cosine, and the cosecant is 1 divided by the sine. Then you can always get the other values. Okay? The tan is the sine divided by the cosine, and so forth. Please go over these reciprocal notes. They should make sense. And make sure you know these 3 Pythagorean identities. Okay? So sine squared plus the cosine squared of theta is 1. The tangent squared plus 1 is equal to the secant squared, and 1 plus the cotangent squared is equal to cosecant squared. We will have a formula sheet. We are finishing that up, It is a lot to remember. You just need to know how to use all of this. Let's try number 4. If we are given that the sine of theta is 5/15/17 and the cosine of theta is 8/17, they want us to use these identities to find the tangent of theta and the cosecant of theta. So we've already talked about that the tangent of theta is the sine of theta divided by the cosine of theta. So you might want to write those out just to see if you can remember. So that's 15/17 divided by 8/17, and that is 15 divided by 8. Now, how would you do that? You could multiply the numerator. Let me do that in a red pen. The numerator and the denominator multiplying by 17, and you could reduce those like that if you'd like. Okay, now let's try the cosecant of theta, and the cosecant of theta is equal to 1 divided by the sine of theta. So it's really just the reciprocal of the sine of theta, and the sine of theta was 15/7. And when you reciprocate, you just interchange the numerator and the denominator. Okay, if we are given that the secant of theta is the square root of 11/3, we need to use an appropriate Pythagorean identity to find the tangent of theta. So I like to go to a right triangle always and see if I can figure out what I'm given. Okay, so if the secant of theta is the square root of 11/3, what did we talk about with the secant of theta? If we look up here, it is 1 divided by the cosine of theta. Okay, so the cosine, and here's theta, the cosine of theta, remember, so toa is adjacent over hypotenuse. So the secant of theta, which is 1 over the cosine, which is 1 over the cosine of theta, that would be the hypotenuse divided by the adjacent side. So if the secant of theta is equal to the square root of 11/3, we already know that our hypotenuse is the square root of 11, and we know the adjacent side is 3. So what can we do now? We can now find this last side here by using the Pythagorean theorem. So let's go ahead and try that. And we can find this missing side here. So we have 3 squared, I can do that over here. 3 squared plus y squared is equal to the square root of 11 squared. So we have 9 plus y squared is equal to 11. Y squared, is equal to 2, and y is root 2. So it's not that difficult if we can just remember to use our x squared plus y squared equals z squared and come up with that. And now we're going to find the tangent of theta. So the tangent of theta, and we don't really have the tangent of theta. We can now use the opposite over adjacent. And how do we know that? SOHCAHTOA. So that's opposite over adjacent. And that opposite side is root 2, and the adjacent side is 3. Okay, now we're going to get to some cofunctions, cofunction identities, and these can be quite interesting. You can take some time to read through these. The sine and the cosine are what we call cofunctions. So the cofunctions of complementary angles are equal. So it's really interesting that the sine of 30 is equal to the cosine of 60 degrees. So how about this? The tangent of 12 degrees is equal to the cotangent of 78 degrees. Likewise, the cosecant of 5 pi over 12 is equal to the secant of pi over 12. So we will be using some of these co-functions, and they're really, really interesting. So maybe you could pause the video and take a look at that, and then we can resume with number 6. So in number 6, if we're given that the cosine of 75 degrees is root 6 minus root 2 over 4, we need to find a cofunction with that same value. So what we're looking for is the complement, because remember what this said. Oops, I think I wrote that in the wrong spot. We have complement angles. Complementary angles are equal, okay? So we're looking at the complement of 75 degrees, and that's equal to 90. Remember, complementary angles add up to 90 degrees minus 75 degrees, and we have 15 degrees. Okay, so now the cosine of 75 degrees is equal to the sine of 15 degrees, and that is equal to root 6 minus root 2 all over 4, which is what they gave us. Okay? And what did we learn here? Right here. The cosine and the sine are cofunctions of each other, right? Cosine, cosine, tan, cotan, secant, cosecant. So when those angles add up to 90 degrees or pi over 2, and pi over 2 is 90 degrees. This is radians and degrees. So that's why we have 15 and 75 equals 90 degrees. Okay, let's look at number 7. Use the fundamental identities to determine if each expression is true or false. We are going to break everything down into sine and cosines. And once you do that, it makes it quite simple. So let's go ahead and take a look at number 7. The cosecant is 1 over the sine, so we have 1 over the sine of theta all squared. And then the tangent is the sine of theta over the cosine of theta. Then we just have the sine of theta, and we have the cosine of theta. So let's see if we have anything that cancels. We have the cosine, canceling with the cosine. We have the sine and the sine multiplied together, canceling with the sine times the sine. And that is truly equal to 1. So that is true. Okay, let's break the tangent down into the sine of theta over the cosine of theta, multiplying by the cosine of theta, and we want to see what that is equal to. So let's cancel the cosine of theta. And we're left with the sine of theta. Now, the sine of theta is not equal to 1 minus the cosine of theta. So this is not true. This is false. Okay, now we will approximate trig functions on the calculator. And this is going to be really important because you want to make sure you check your mode. So you either need to be in radian mode oh goodness. And I will show you that, okay? So for the cosine, we have the cosine function on our calculator. So let's go over here first. And what do you notice that we have? We have degrees, okay? Let me write that. So we have degrees here. We need to be in degree mode. So as you can see, if you come over to your calculator and you take a minute and you can see that mode is right here. And we are in radian mode, so we need to go to degree mode. And then just second quit. And now we can press the cosine button, the cosine button, and type in 74.82. And that is recognizing that in degrees since we are in degree mode. And I don't know if that went to degree mode, so that's really important that we do that. So I want to make sure I didn't press enter. So that was actually a really good thing to happen. It didn't look right. So second quit, and let's check that again. You can actually press an arrow up and go and get what you previously had typed. And press enter. And now we got the correct. So I like to use the arrow up so I don't have to retype. And now you can see that the cosine of 74.82 is about 0.2619. They've asked us to round to 4 decimal places. Okay, what do you notice about this next value? We need to be in radian mode. So we're going to go back to mode. And now we're going to go to radian and press enter this time. Second, quit. And we will type in. Now we don't have a cosecant button. But what do we know about the cosecant? That is equal to 1 divided by the sine of 2 pi over 5. So we're actually going to put that in our calculator. So we're going to type 1 divided by the sine of 2 second pi divided by 5. Thankfully, those parentheses are already there for us, and we end up with 1.0515. Okay. I will leave that calculator here if it'll stay small. Well, I'll bring it back up so that the notes can be seen. And we have 2 problems that are applications, and that will conclude this section. We will draw a triangle. First. Okay, so we have a 28-foot water slide at a water park, and it makes an angle of 60 degrees with the ground. So let's go ahead, and we have this right angle, and we have a 28-foot slide. So this side is 28 feet, and here is 60 degrees. Okay, and then it will descend into the pool. So I'm going to use this value as y, this value as x. And so what do you notice? They've asked us to find this vertical distance from the top. So they want us to find y. And you can let that be any variable that you like. Okay? So what do we need to do? We need to see what we have. And what we have is what? With respect to the angle 60 degrees. With respect to 60. We have a hypotenuse and we have opposite. So what do we use for O and H? You guessed it. That is the sine. So that is the sine of the sine of theta is equal to the opposite over the hypotenuse. Okay? And that is going to equal y over 28. And we could even erase this. Okay? So now, what are we going to do? We can type, I should have put 60 because we knew that the sine of 60 degrees, let me make that a little bit bigger, is equal to y over 28. So what could we do to both sides? We could say that y is 28 times the sine of 60 degrees. And if you go ahead and write that out, remember that the sine of 60 degrees is the square root of 3 over 2, and that's 14 root 3 feet. Now, you can also put that in your calculator and get an approximate value. Move this over a little bit, maybe make it a little bit smaller, which is about equal to, and if you put 14 multiplied by root 3, you'll get about 24 feet. Okay, our last problem. An observer on the roof of a 40-foot building measures the angle of depression. So you will need to know what that means. And an angle of depression is this right there. So that is 24 degrees. Okay, and It's a 40-foot building, so you guessed it. We have a 40 on this vertical distance, okay? Now we don't know what our x value is. We also don't know what the hypotenuse is. But if we read the question, they say that the angle of depression from the roof to the ground is 24 degrees. What is the distance from the base of the building to the bench? Okay, so they want us to find x. Okay, the base of the building. X is the distance to the bench. Okay, so what you probably remember from geometry is that we also have this angle as 24 degrees. Okay, so now we have a nice triangle. With respect to 24 degrees, what do we have? We have opposite and we need adjacent. So which trig function uses opposite and adjacent? It is the tangent. So the tangent of 24 degrees is the opposite over the adjacent side, which is 40 divided by x. Okay, so I want to talk about this for a minute. Let's rewrite this as the tangent of 24 degrees is 40 divided by x. If I place this over a 1, we can cross multiply, or we can do lots of things, but basically we could cross multiply and then we could divide by the tangent. So x tan of 24 degrees is equal to 40. So x is equal to 40 divided by the tangent of 24 degrees. So when you put that in your calculator, you will get about equal to, and let's see if I can move all of this up a little bit. Probably giving you a little time to think here. And I really wanted to highlight what they want us to find once we read the problem. And then the 40 divided by the tangent of 24, make sure you are in degree mode and you'll get about 90 feet. And this concludes this section.